Alrighty, I want to jump into 2.12. We are continuing with our study of inequalities. The start thinking part got the students to practice what they learned yesterday. You just had a basic inequality with just one variable, and after solving it, they had to graph it. If you solve this inequality in one way, you would end up multiplying or dividing by a negative. That would be if you subtracted 5x from both sides. But the way I did it is I subtracted 2x from both sides, and that made it so I did not have a negative coefficient on the x, and I did not have to switch my sign. So once you went over and solved doing that, you end up with x is greater than -3. You put your open dot at -3, meaning -3 is not a solution, but that's where the solutions start. And then you can graph to the right. The way I knew to graph to the right, I know a lot of people just say greater than means graph to the right, but if you switch this inequality, it would have been -3 is less than x, which is equivalent to this, and you would have thought to graph to the left. So the best way you can do this is just pick any point on the left or any point on the right, see if it's a solution. If it is, shade on that side, and if it is not, shade on the other side. Um, I brought up something that we had done in previous lessons, and that was that the curriculum really wanted students to understand that if you had a inequality, if you just change it to an equation, that will tell you where the border is that splits up the solutions from the non-solutions. So if you change this to an equation, solved it, you would get x equals -3, and that means -3 is going to be the location that divides the solutions from the non-solutions. What we were doing in today's lesson is instead of having inequalities with just one variable, we had inequalities with two variables. So we had y is greater than -3/4 x plus 4 to start with. The students worked through a process and learned how to graph this inequality. The first part said, what is the boundary that divides the solutions from non-solutions? Think about how we did this before. And a second ago, I told you that if you change the inequality to an equation, it kind of tells you the border between the solutions and non-solutions. So we knew y equals -3/4 x plus 4 was going to be that border. The one thing that you need to know is when you graph as if it was just a normal equation, you have to put a dotted line if it is less than or greater than, and if it's less than or equal to and greater than or equal to, or one of the two of those, it has to be a solid line. And the meaning behind that is that not only are all the shaded parts going to be solutions, but on the line would be solutions if it was solid, and on the line would not be solutions if it was dotted. So after we had that, we had to figure out which side, it was either above or below that the solutions would be. So just like we tested a point on the left or on the right of our point when we were doing inequalities with one variable, when you have two variables, you end up having points. So we are going to test a point, either any of the points below the line or above the line. When you do this, a lot of times, unless the line is going through 0, 0, you like to test out 0, 0. So when I try 0, 0, you end up getting 0 is greater than 4, which means 0, 0 is not a solution and it can't be shaded. Therefore, none of that side can be shaded. It has to be the other side. The way I explained this was this is kind of like if you were wandering through the forest up north and you got to a border, and one side was Canada and one side was the US, and you didn't know which side was which. But in our world, the Canadians stayed in Canada and the Americans stayed in the US. One thing you could do is just ask a person on one of the sides, are you American? And if they say yes, then that side is the US. And if they say no, then the only other option is the other side. You would never ask a person who is scaling the fence at that exact moment, hey, are you American? Because if they say yes, that wouldn't help you know because they're in kind of no man's land by being on the actual fence. Just like if you tested a point on the line, that doesn't tell you which side is going to be the solutions. So once again, you are going to graph it as if it is just a normal equation, dotted versus solid, depending on if it is less than or greater than, or if it's less than or equal to and greater than or equal to. So if you have that equal part of it, then it has to be solid. Otherwise, it does not. Then you test a point on either side, and if it is a solution, shade that side. If it is not, then shade the other side. There's only two possibilities. One side is all the solutions, or the other side is all the solutions. The next thing the students did was they did a process of elimination, and they were trying to figure out which one of these inequalities went to which graph. And the first thing they noticed was that all of them had 2x minus 5. So that didn't help us at all. We couldn't differentiate between y-intercepts and slopes or anything like that. What you could notice is that some are dotted and some are solid. And the other thing is that some are shaded above and some are shaded below. Now, here's the thing. If you have the equations in slope-intercept form and the y is on the left-hand side, then you can confidently say greater than means shade above and less than means shade below. This is only true if you have it in slope-intercept form, like all of these are, and the y is on the left-hand side. So on number 1, it is just greater than, which tells me I do not have to look at anything that has the solid line, only the dotted line. After that, it says that, so that is the last two. And then after that, you can see that it is greater than, and it is in slope-intercept form. So I know it's the one where you shade above. The other thing you could have done is figured out which points are shaded, take one of those points and see if they actually make the inequality true if you're between two different ones, if you don't know if you're shading above or below. Take a peek. You can see which ones match up with which ones. We did this by finding out if they were dotted or solid lines and then figuring out if they should be shaded above or below. After that, the students worked on solving and graphing, or getting these two inequalities into slope-intercept form. And then after you had that, graphing it, either doing a dotted line or a solid line. And after you have that, picking a point, testing if it is a solution to figure out which side to shade on. The first one, 0, 0, you can see the line goes through 0, 0. So you're not allowed to test that point. You can test any other one. And I thought that 1, 1 was the next easiest point to test. As you can see here, you cannot graph a linear inequality unless you can graph a line. So if you're still struggling with graphing lines, you're not going to be able to do this until you fill in that. On number 2, the only change that I made is in one of the periods, I decided instead of it being a positive 2y, I made it a negative 2y. And the reason why I did that was so that the students would have to divide by a negative 2, which would have forced them to flip their sign. In the problem that you're looking at, I left it as a positive 2y. So they did not have to switch their symbol. After they graphed, they tried 0, 0 to see if it works. Since it does work, you shade on that side. If it didn't work, you'd shade on the other side. On this next one, we are able to know that it is y, the slope is negative 2/3, and then we have x, and the y-intercept is 3. So I did that first. I saw it was dotted, so it was either going to be less than or greater than, and since it is shaded below, I knew it was going to be less than. Once again, I was only able to say this because it is already in slope-intercept form, and the y is on the left. The next one was asking if these points were going to be shaded once or not at all. So all we had to do is see if they're solutions. We found out that the first one is not a solution to the inequality, so it is not going to be shaded. The second one is a solution, so it will be shaded. And the next one, not only does it not make it true, but since we have 5 is greater than 5, I knew that that was going to be on the line. That's actually on the line that is dotted. And since it's dotted, it's not going to be a solution. If it was solid, it would be a solution because that would have said 5 is greater than or equal to 5. All right. After that, we started looking at the homeworks. On this homework right here, this first one here says what are the points that would not be appropriate to test if you were trying to figure out which side to shade on. The main requirement is you cannot test a point that is on the line. If you test a point that's on the line and it does work, then that doesn't really tell you which side to shade on. So when we look at this, the points that are not on the line are 0, 0, and 4, 5. So you can use either one of those to figure out which sides to shade on. The next one on here, it was asking what are the mistakes the person made when they were graphing. When you look at this, you see that it should be dotted, and also they shaded on the wrong side. They should shade down below. On these ones right here, I intentionally on 3a gave you 3 is less than y, thinking that you would go over and graph below because you see less than. The reason why that is happening is because you have the number on the left and the variable on the right. If you switch this around, that'd be y is greater than 3. And when you see that y equals 3 is a horizontal line, it'd be dotted. And then if you tested a point, let's say you tested 0, 0, 0 is 3 less than 0, 3 is not less than 0. So you should not be shading down below, you would shade up above. The next one, you have your y-intercept of 5, go down by 2 over by 5. It's going to be a solid line. When you test 0, 0, you get 0 is greater than 5, and 0 is not greater than 5. So 0, 0 can't be shaded, and none of his little friends down there can be either. And you have to go over and shade above. Since this is in slope-intercept form, and the y is on the left, you already can see that it is greater than, it should be shaded above. The next one, we had to get this thing into slope-intercept form. You had to be careful because when you divided by a negative, you had to switch your sign. You end up getting y is greater than 2/3 x minus 4. That means that you have a y-intercept of -4, and it's up 2 over 3, up 2 over 3, dotted line, and then you would test 0, 0. I would test probably the original one. That's 0 minus 0. 0 is less than 12. 0 is less than 12. So that means that you would shade where 0, 0 is, which is up above. On this one right here, it says determine if the following points would be shaded or not shaded. Remember, shading means that they are solutions. So when you test out 1 comma 4, it is not going to be shaded because it is not a solution. You end up getting -3 is greater than 10, which is false. On the second one, you end up getting 48 is greater than 10, and 48 is not greater than 10. 48 is greater than 10. So since it's a solution, it would be shaded. All right, I wanted to add one of these review problems here. On this problem, it's talking about a person who went and bought a pair of pants and a shirt, and they had a certain cost, and then they liked the shirt and the pants. They went back and bought more. On the second time, they bought 3 shirts and 5 pairs of pants, and the total was $75.75. It's asking what is the cost of a single shirt and a single pair of pants. So what we had here was that first equation was S plus P, a shirt plus pants. When they bought one of each, it was $20.25. On the bottom, it was 3 shirts and 5 pairs of pants, and the total was $75.75. And with that, it was stacked and looked like it would be best done by elimination. So I multiplied the whole top equation by -3 and I solved, and I was able to get a pair of pants being $7.50. And once you know that it's $7.50, then you can substitute it back in and solve for the cost of a shirt. And you find out a shirt is $12.75. I want to make sure that you guys are always keeping up on your abilities to solve by elimination and substitution. All right, thanks for watching.